Hello all. So welcome to the last lecture of the course in Module 14. You guys, we made it. This is the last one. Hopefully it's not going to be too terribly long. We're going to wrap up this course by exploring the emerging trends and technologies and applications that are out there that might be some buzzwords that you've heard in the past. So let's get started. We're going to look at where this industry is headed in software, virtual reality, cloud computing, nanotechnology, blockchain technology, and cryptocurrency. Finally, we'll wrap everything up by kind of exploring just a little bit into quantum computing. So let's get started with trends in software and service distribution. The idea behind a push and pull technology that's been around since web design first started. So let's take a closer look at both of them. First, with pull technology, the user is going to state their need prior to them getting their information. For example, the user needs to purchase a specific item. They're going to go to a specific URL, say Amazon.com. This technology works great for purchasing and for already known products. Pull technology, on the other hand, it works best for marketing. Okay, so instead of waiting for a user to request information, your favorite web content can actually be pushed and delivered to you in real time automatically. It's going to create a relationship between customer and their organizations. Okay, some examples of push technology include the notifications that you get on your phone, whether it be ESPN or like text apps, and even email push updates. Back in Module 7, we talked about internet service providers, or these ISPs. An ISP offers internet service in exchange for a fee, right? That's something like Spectrum or AT&T. An ASP, on the other hand, is an application service provider. They're going to provide software or applications for a fee. See the common denominator, the fee part, right? It's used a lot in cloud computing and known as SaaS or SaaS, or software as a service. The software can be long-term use, short-term use, it doesn't matter. The most recent version and updates are quickly available to your user and typically allow your users to save information on those ASP servers. Some examples would include the Google Apps, Office 365 tool sets. This software can be used for generic use, specific purposes, or vertical market, which would be a solution for specific industries such as doctors or lawyers. Advantages of using ASPs are that your software is always up to date. Your customer always knows that they have the most current. Sorry about that. The information system employees can concentrate on other aspects of the business model instead of concentrating on that technology. Cost is spread among many different customers using the ASP, and it's not just typically paid for by one organization. Technical support is typically included in these fees that are paid. And finally, the fee is a predictable monthly fee and not a one-time large lump sum. There are some disadvantages though as well. Users cannot modify the applications and they have to use them as they're provided. There's typically minimal, if any, customization of the software allowed. There is a risk that the off-the-shelf software is not going to fully meet the needs of the organization. And finally, integration with other types of software already being used by the organization might be challenging if the software applications are not compatible. Now, let's transition into virtual reality, or VR. This is where computer-generated three-dimensional images are used to create the illusion of interaction in a real-world environment. The simulations use things such as sound, lighting, graphics, all working together to give that 3D appearance in a 2D space. A VR environment can have interaction between users and objects, giving users that immersive experience, feeling like they're part of the environment and not just looking at it. Telepresence is when the user is given the sense that they are in another location, possibly another geographic location, and they can manipulate objects as though they were in that location. So for example, I'm sitting here in North Carolina. I could do a VR telepresence to the Louvre in Paris and interact with museum displays. Full body immersion allows users to move freely about the environment using cameras, monitors, and other types of devices. Finally, networked communications allows users in different places to interact with one another and the environment for which they're in. This is going to connect the two environments and kind of put the two users into one virtual world. Two main types of environments found in VR. The first is an egocentric, the next is an exocentric. Egocentric, ego looking inward, okay? The user is totally immersed into the VR and actually becomes part of that VR environment. Technologies include those head-mounted displays, the visual retina displays. Exocentric, on the other hand, that's going to do is it's going to give your user a look into the environment. The user's not an actual part of the environment. It's just an observer of that environment. The data can be viewed, but not interacted with. Components of any VR system can be broken up into four major categories: visual, manual, central coordinating processor, and a walker. The visual and oral systems allow the user to see and hear, where the manual control for navigation allows the user to navigate and interact manually with the VR environment. The central coordinating processor and software system generates and manipulates those graphics that are making up the environment, and it'll display them in real time. A very, very fast processor is needed in order to make these environments as lifelike as possible. And then finally, you have a walker. This is going to capture the movement of the user within the environment, typically leg movement to like walk, run, and to allow actual exploration of the environment. Here's an example of a virtual environment called a cave automatic virtual environment, or just a cave for short. A cave, in essence, is a VR room where all the walls are projection screens instead of typical walls. Holographic devices project 3D images for the user to interact with. Caves can be used for research in many different fields, such as architecture, engineering, physics. Engineering companies, for example, use the cave to improve product design and in development phases. A cave is really just a fancy prototyping tool. VR is great, but why and how can we use it, especially outside the gaming world? Most people know how to use it within gaming. Well, it can be used for flight simulations or surgery practices. The New York Times uses VR to view news stories in an immersive 360-degree environment. VR can be used in assistance to the disabled, in architectural design, in education for simulators or exploration, and finally, in video conferencing settings. The major hurdle for VR currently is not having enough cable to carry the data, okay? But that doesn't mean there's only that one issue. Some of the other issues include confusion between environments. Am I in a VR environment? Am I in a real environment? Mobility issues, sound replication, and the need for immense computing power in order to successfully create and manipulate your VR environment. Now, you can take VR one step further by creating a virtual world. A virtual world is a simulated environment designed for users to interact in. Typically, each user creates an avatar, which would be a 2D or 3D representation of themselves. And that avatar is what's going to live in the virtual world. This is used by gaming, chat rooms, entertainment mostly right now, but there are some business applications. Some of the most popular virtual worlds that you may have heard of are Second Life, or even games like World of Warcraft, Minecraft, Skyrim. These are some of the popular implementations of the virtual world. Now, augmented reality, or AR, is a type of virtual reality. AR is going to generate a virtual scene overlaid on top of the real object. The whole goal is to enhance the user's perception of real-world objects that they're seeing or that they're interacting with. The difference between augmented reality and virtual reality is that the AR user stays in the real world while they're interacting with objects. There's an awareness that the user is still in the real world. Okay. Remember, VR is immersing those people into the virtual world, blurring the lines between virtual and reality. Okay. Your mind as a user is tricked into thinking you're actually someplace else. A great example of augmented reality is the Pokemon Go game. If you've not played it, congratulations. But Pokemon Go, these Pokemon objects are actually overlaid onto your camera, and you can actually see a mixture of what you're actually seeing in reality with the virtual environment placed on top of it. Now, mixed reality or a hybrid reality, this is going to fall somewhere in between. Okay, we always have that in between. This is the area where your flight simulators are going to fall. They combine the virtual reality and augmented reality by merging the real and the virtual objects to create a brand new environment to interact with, right? In the simulators, you're actually at a location which has real-time data, but you're there virtually, right? The user remains in the real world environment where the digital contents are added. Switching out of the VR world, let's take a look at cloud computing. Some of the most popular applications of cloud computing include the fact that it's scalable usage through subscription models such as Netflix or Hulu, chatbots such as Siri or Alexa, worldwide communication tools such as Skype or WhatsApp, global productivity tools like your Office 365 or Google Apps, and business process and enterprise systems such as Adobe Systems or Salesforce. Backup and recovery such as Dropbox or OneDrive, application development such as Amazon or Blender, test and development such as BlazeMaster, big data tools, analytics, and finally social networking sites, Facebook, LinkedIn, Twitter. Grid computing is the next trend we're going to take a look at. This is going to combine the processing powers of various different computers and allow them to work together. Users can use resources from other organizations to solve problems that might be too large or too complex for their own computers. Each participant is seen as a node on the grid, like in the picture. Typically, this is used for financial applications or other very large-scale complex issues. The advantages of grid computing is an improved reliability, the ability to parallel process at the same time, and the ability to quickly scale your resources to your needs. Now, some disadvantages to grid computing are that some applications are not suitable to run in the grid computing environment. Okay, applications are going to require extensive memory, cannot be used. Licensing agreements become challenging across these computers. Synchronizing operations in several different network domains can be difficult. Grid computing does require sophisticated network management, and some organizations are resistant to sharing their resources, even if it's to their benefit. The next trend we're going to look at is utility or on-demand computing. This is the provision of IT services on demand. Users will either pay for computing or storage resources on an as-needed basis. The advantages are that you only pay for what you are using and the convenience behind that availability. The disadvantages include security and privacy, our usual, right, of the information being used because it's actually on an external source. This can be used with the software as a service or that SaaS model by enabling your user to request the power and memory required for execution. And again, you're only going to pay for what you use. Cloud computing in general incorporates many different technologies all under a single platform. Some of the that's not a word. Some of the components include infrastructure, platforms, or software. Distributed computing has many advantages and disadvantages. Advantages include the ability to request components as you need them. But a disadvantage is that most components are fee-based, so you're going to pay per component. Organizations have 5 different types of cloud models that they can choose from. Typically, your choice is based on your security needs and the extent of your involvement of your organization. First, a public cloud connects users with an off-site infrastructure and is shared by a very large number of users. A private cloud is going to give you the same capabilities as the public, but it's housed on a private network, so you have much tighter control over the security. A hybrid cloud is typically chosen by organizations that use both public and private. The hybrid model has access to at least one public and one private. A multi-cloud organization uses more than a single public cloud. And finally, a community cloud has infrastructure designed for a specific community or a specific set of users that share a common concern. Next, we're going to look at edge computing. Edge computing is going to play a major role on the Internet of Things realm, that IoT area. Edge computing pushes that processing and data to the edge of the network, enabling a timely collection, processing, and analysis of the data. The advantages of this edge computing include real-time analysis of data, lower operating costs, enhanced scalability, reduced network traffic, and improved application performance. Where traditional and conventional cloud computing is vulnerable to denial of service attacks and power outages, edge computing is distributed among various other devices, and it is difficult to disrupt or take down completely. Organizations that use cloud computing should provide end user education, force software updates, and work with their cloud computing providers to spot unusual activities. This will keep the security concerns to a minimum when using the cloud computing platform. Cloud computing may be more secure than on-premise data centers. Top cloud providers can employ security subject matter experts, okay, which may be way beyond the affordability or availability to an organization. Your data is stored physically on a server where a location doesn't matter. So this makes a physical attack much less likely. The cloud providers have many more resources to find and fix vulnerabilities before hackers can exploit them. Public cloud providers make it much more likely that you can recover from an unexpected disaster. And finally, cloud providers use the latest and greatest of technologies, always keeping on top of what's considered state of the art. Now, that saying, there are several security risks that should be considered when transitioning into a cloud computing platform. Like number one, who has access to your data? What is the external audits and security certifications? What are the specific location restrictions that you must take into account? How is your data kept separate from others? What will happen if your data, if there's a disaster? What type of support is offered if an investigation is needed? And finally, what will happen to your data if your cloud provider goes out of business? Now let's switch gears a little bit and talk about nanotechnology. Nanotechnology is going to incorporate techniques that involve the structure and composition of a material on a nanoscale. Now, just for reference, a nanometer is 1/1000th of a meter. Okay, so that could kind of get your wheels turning. When we think of nanotechnology, we think of places where very small computers might be helpful, right? In healthcare, to unclog arteries, to find cancer cells, etc. In energy, to use to reduce consumption, increase efficiency, and even create a more environmentally friendly energy. In information and communication, building a smaller, faster, cheaper computer, that's what everyone always wants, right? And then finally, in heavy industries such as aerospace, construction, and vehicle manufacturing. Some consumer goods are already do incorporate nanotechnology. They're called nanomaterials. You can find them in tennis and golf balls, in sports gear, and in clothing. Sometimes nanomaterials are used to cut down on bacteria growth within your clothing. Finally, we're going to take a look into blockchain technology and cryptocurrency in particular. A blockchain is a decentralized and distributed network used to record transactions across connected devices. The data cannot be altered after it is recorded. Once they're recorded, they're grouped together in blocks and then they're linked together in chains. Hence, it's called a blockchain. Typical applications of blockchain technology include tracking of food and goods, secure software development, and digital content management. For these three applications, the blockchain is typically used for security and accuracy of information they contain. Blockchains can also be used to improve the integrity of healthcare records by making records secure yet available to outside doctors and health and medical personnel. The mortgage approval process and insurance claim processes both use blockchain technology. Storing of information is secure, shared between companies, whether it be a potential lender or an insurance company. A blockchain database provides unaltered data, which can be used during an audit. A blockchain network can be used for electronic voting or for smart contracts. Smart contracts are typically contracts where funds are automatically transferred between two parties as soon as a certain condition is met. Now, cryptocurrency is probably the most popular of the blockchain technologies. Cryptocurrency is digital money created from computer codes, monitored by a peer-to-peer internet protocol. An individual holds a public and a private key. That's what makes up your cryptocurrency address. There are no third-party banks or financial institutions involved. Probably out of all of those popular types, the most recognizable is the Bitcoin, but notice there are a ton of other types out there. Since cryptocurrency is a peer-to-peer operation, it can take place anywhere in the world. Some of the other advantages include that it cannot be counterfeited or reversed by the sender. It is an immediate transfer. Therefore, the buyer is safe. They also have lower transaction fees, and there is no risk for credit theft. Now, there are also a bunch of different disadvantages. It's not yet widely accepted. There is no way to reverse the payment, which happens to be an advantage to the buyer, but a disadvantage to the seller. There's also a lot of uncertainty with respect to regulations and who regulates what. There is a potential for financial loss due to data loss and a potential for high instability and manipulation. And cryptocurrency is not in any way, shape, or form exchangeable to any more traditional currency, such as the US dollar or a euro. The final topic for this entire class and this entire lecture is quantum computing. Quantum computing uses quantum mechanics that generates and manipulates quantum bits. These quantum bits are called a qubit, and it's sort of akin to a binary digit or just a bit. Quantum computing is not intended to replace a personal computing, okay? They are typically not good for large general applications. Quantum computers are created to be very fast for a very specific reason. For example, some companies use quantum computers to develop lighter and more powerful batteries for electric cars, or to help create effective new drugs. Quantum computing has a very diverse group of applications, including in aviation, computers and network security, forecasting, data analytics, pattern matching, pharmaceutical research, and even in self-driving cars. So we've talked a lot in this lesson about all the different advancements and trends going on in technology. We started out talking about the most recent trends in software and service distribution, including the push and pull technologies, ASPs, SaaS. We explored how virtual reality uses 3D images to create an illusion of an interaction in a real world environment, and how VRs use components that integrate visual, oral systems, manual navigation control, central coordinating processors, and a walker to present the most realistic 3D experience to that user. We talked about recent trends in networking technologies, including grid computing, utility computing, cloud computing, edge computing. We touched on cloud computing and how it incorporates SaaS, grid computing, utility computing to provide a wide variety of resources over the internet. Next, we talked about nanotechnology and how it's being used to incorporate techniques to manipulate those nanoscale materials in areas including energy, information and communication, and heavy industry. We then discussed quantum computing and how it uses quantum mechanics to solve problems considered impossible for classic computers. Okay. Last but not least, we looked at blockchains and saw how that is a decentralized and distributed network connecting devices such as blocks of data that cannot be altered once it's recorded. Finally, we went through cryptocurrency as one of the most popular applications of blockchain technology. I sure hope you guys have all enjoyed this course as much as I have. Thank you all so much for all your hard work and your dedication during this really, really, really tough week. But just think, you're one class closer to graduation. So I hope to see all of you on campus very soon after all of this COVID mess. And if you ever need anything, I am just a phone call or email away. So I just want to say goodbye and good luck. Bye.